Beauty can be found in the most unlikely places. Beetles can have the most spectacular coloration, their polished elytra rich enough to challenge even the most imaginative creators. Insects, the most numerous, strange and diverse group of living creatures inhabiting Earth. Armored, flying, digging, predatory, solitary or communal. The same name is used for them all, although the simple formula of head, thorax and abdomen, together with their flight system, covers an almost infinite variety of combinations. Thousands of years after their ancestors arose from the sea, insects conquered the land. And once they had done that, they miraculously obtained wings to take to the skies. The air, the only place without borders, is the domain that has been, since the earliest times, a focus for mankind. It was conquered by insects thanks to the magical gift of flight. This ability, developed over the course of their evolution, allowed insects to move into many different habitats inaccessible to other animals. Some did not manage to achieve the power of flight, but the majority developed a physical quality that they alone were to possess for 100 million years: wings. The seeds of these creatures' success were planted even before this. After the first forms of life moved from sea to land, nature brought about the development of hundreds of morphologies, all channeled towards winning the struggle for adaptation to the different environments. This was the key to their biological success. Flight allowed them to move around, to reach new frontiers and conquer every spot on Earth. In the Carboniferous period more than 300 million years ago, there were already winged insects that, in the case of the dragonfly, measured up to 75 centimeters in length. Over time, all species changed and diversified the shapes, sizes, and functions of their wings. The adaptation to flight sculpted the body of the insects, making them lighter and more aerodynamic. Of all the morphologies created by the diversification of life, the most successful was to be that of the beetle. An infinite number of creatures conquering every imaginable habitat, evolving to adapt to them, even ready to fly, and also to return to their ancestral home under the water. The very same capacity for adaptation that allowed these animals to be the first to colonize the land also made it possible for them to conquer the water. Water, closely linked to the fate of the planet, not only as the origin of the first forms of life, but also as the setting of countless epic journeys, such as its silent and ancestral conquest by these tiny creatures. The conquest of water was possible thanks to incredible processes of adaptation, such as those of the water scorpion. To take in air, it developed a long tube that is so unlike the terrible weapon of its distant terrestrial relative. This is a kind of periscope made up of two hairs which, when joined, form a tube. It uses this to breathe as it cautiously peeps out of its refuge, without leaving the mud that shelters it. Another curious adaptation to the aquatic environment: mosquito larvae. They adjusted to life upside down, breathing through a tube at the end of the abdomen. Temporary bodies of water became home to many species, obliged to adapt to the changing nature of their habitat. Other species adapted to the pure waters of mountain streams, species that would not be able to live in a polluted environment. 250 million years ago, stoneflies had colonized every continent except Antarctica. From sea level to Himalayan altitudes, their waterborne larvae developed laminar surfaces for breathing which work like gills. With rhythmic speed, as if they wanted to compete with the movement of the water surrounding them, they moved the blades located on both sides of the abdomen in order to capture more oxygen from the water. Their flat bodies seem to have been modeled by nature to stop the current from carrying them away. However, their case is not unique. This other species also developed a useful hydrodynamic shape, although it has to resort to another system to breathe. Since its gills do not have the power of movement, it is the animal itself that moves them, like a disciplined athlete carrying out a strange gymnastic exercise. Many insects adapted to the water, keeping their form of respiration unchanged from their terrestrial origin. So they developed strategies aimed at obtaining and renewing air through their tracheas, all the time ensuring that water did not enter them. For this, they need to go to the surface. This is the case with water beetles. They have a space under their wings that can be filled with air, a little like a diver's air tank. When this reserve finishes, they have to fill their tanks again at the surface. Once there, they open the hatch located at the ends of their bodies, and they take in the air they need, while also secreting oily substances that prevent water from entering. Once this operation is complete, they submerge once again. The shores of lakes and ponds have been colonized by a great number of different insects that have built true underwater cities. To breathe, this silver beetle goes to the surface with its head up and breaks the surface of the water with its antenna, forming a channel to fill its tanks with air. This is one more unique example of adaptation to the water environment. The insect's body is surrounded by air, adjusting to each part like a second skin and creating a surprising effect. It gives the creature an intense silver color. After storing air, it is essential for it to go back to the subaquatic world, where the silver shade of the insect symbolizes the fact that air is necessary for life underwater too. The struggle to adapt to and settle in other places on Earth has favored diversity, to the point where two or more different species originate from a single one. Insects of the same kind, physically separate and subject to the variations of the weather conditions, gradually change their morphology, resulting in two different species. In some cases, this difference is the result of geographic isolation. The best example of diversity is in the heart of tropical rainforests. There, in an area equivalent to half a football pitch, 4,000 different species were identified. And we are only talking about beetles. Today it is thought that there are around 200 million insects for every living person on the planet. Considering this piece of information, it seems clear that insects deserve more attention from human beings. But what is the reason for such extraordinary success? Insects have some morphological features that are so effective they could be considered true gifts from nature. The first of these gifts is the exoskeleton, an external skeleton that insulates the insect's body and allows it to survive in every possible habitat. Its small size also helps, since it allows the insect to settle in places forbidden to other larger animals. The external skeleton is the key to insect success. It is an articulated shell that covers the whole body and effectively protects its fragile organism, while allowing the insect to move. The external skeleton is made of chitin, a material that is both hard and light, and it also carries out other basic functions for the survival of these animals, such as protecting them against injuries and preventing water loss. Insulated from the environment by their cuirass, they can adapt to life in the ice of the Arctic and withstand the desert sun. Depending on the species and its needs, the external skeleton has different characteristics, especially in terms of its hardness. The physical appearance of these tiny creatures is an indication of their great diversity, and it reveals itself in a multitude of unimaginable shapes, colors, and designs. Mankind has at hand an immense range of ingenious solutions that he can learn from when searching for answers to his own design problems in order to meet human needs better. The variety of their morphologies means that occasionally it can be a difficult task to identify the insect's body parts, head, thorax, or abdomen. The head is the location of the basic sensory organs. The eyes and the antennae are the animal's computer sensor, providing the information needed for it to interact with its surroundings. The eye's strange lack of expressiveness is something that strikes us about insects' heads. These are eyes made up of light-sensitive units that can be found in groups varying greatly in number, up to almost 30,000. Certain flying insects, such as butterflies, require visual effectiveness that, in the majority of cases, is denied to most other insects. The compound eyes of butterflies are well developed enough to locate food and move towards it. Visual effectiveness, as well as the size and shape of the eyes, is very similar among the different species of butterfly, although they may have very different colorations. The eyes of some predatory insects, like this dragonfly, have developed enormously in order to improve vision during flight. In fact, they can even join at the top of the creature's head, providing a magnificent 300 degrees of vision. Head, thorax, and abdomen, a simple formula exemplified in thousands of different designs, each one more ingenious than the next. In many cases, insects have 2 pairs of wings, but always 3 pairs of legs. The adaptations and modifications of their bodies for movement on land are so numerous that practically the only thing that insects have in common is the number of legs. This is a rule that caterpillars only appear to contradict. The first 3 pairs are true legs, the others are false, simply helping the insect to support itself and move around the plant on which it is feeding. This great jump, which proportionally speaking no human being could imitate, is possible thanks to the grasshopper's rear legs, a powerful mechanism adapted for jumping. The variety of habits in beetles has favored a wide range of changes to their legs based on a basic model. Each of the legs of these insects is a set of articulated cylinders that has great mobility. The burying beetle lives up to its name. It uses its shovel-shaped 4 tibia, applying its powerful muscles and becoming an ideal drilling machine. A number of variants have developed in the underwater kingdom. Here the beetles' bodies are in the shape of a boat, and their legs have acquired the functions of specialized fins. In the case of other insects, their legs work just like oars. Movement in this medium is as effective as on dry land. However, in terms of resources for movement, insects are not simply limited to their legs. Symbolized by the rhythm of the unfolding of butterflies' wings, a new world of possibilities opens up to insects with the power of flight. The diversity presented by insects' wings can be classified into just 2 flight systems. In the first, the insects beat the 2 pairs of wings independently. These are the least evolved species. In the second, they beat both pairs of wings synchronically and at speeds that are often beyond the capacity of the human eye. It is precisely the fact that the wings have a synchronized beat that produces the insect's well-known buzz. The second type of flight is more common, and the one used by the most evolved species. However, both types of flight have one common characteristic: the large amount of energy needed to carry them out. Insects obtain this energy from 2 sources: the food they take in and the oxygen they breathe, which allows the combustion of reserves. Of course, the wings are essentially used for flying, but flight is something that can materialize in many forms, such as the modifications of the basic model of 2 pairs of membranous wings. This primitive formula has mainly resulted in slow, weak flight, with the insect almost being carried along by the wind. Membranous wings, 2 pairs of fine sheets sustained by a network made up of nerves. As if there were hinges, the membranous wings of some species have a very complex longitudinal and transverse nervation. The larger the surface of the wings, the less evolved the insect. Some species make short, imprecise flights, while others fly with impressive agility and speed. Other variants arose from this basic model, and so there are many species that present different types of membranous wings. However, this system can also act to develop very effective flight abilities, like the one that characterizes this group of insects. When they are resting, damselflies fold their wings into a vertical position above their bodies. This is what differentiates them from dragonflies. It might be thought that the system of beating the two pairs of wings independently is due to a lack of evolutionary capacity. However, the species of this group have kept the system precisely for its effectiveness, which allows them to hunt, mate, and even lay their eggs while in the air. Membranous wings are also a characteristic of Hemiptera, wasps, bees, bumblebees, and ants. Approximately 145,000 species are known. Two pairs of small yet enormously effective wings joined together by hooks during flight so that they work together as a single pair. All these species in this group are excellent flying creatures, although ants are the exception that proves the rule. Their wings are temporary, and they only have them when founding new colonies. The group of dipterians, flies, horseflies, mosquitoes includes those insects that are most bothersome to human beings. There are almost 85,000 species. Their back wings have undergone a curious transformation and have become a kind of drumstick called haltres, full of blood and with nerve endings that allow them to keep their balance during flight while informing the insect about position, direction, and air currents. In some species, the result of such meticulous sophistications is a flying ability that is so effective that it makes us think of some insects, like this mosquito, as pilots preparing to take off for some remote place. It is with good reason that it is one of the animals whose wings are most specialized for flight. Evolution has created other variants to the concept of two pairs of wings, such as in the case of the grasshopper. The surface area of the first pair has been reduced, and they have also been hardened to protect the second pair when they are resting and act as stabilizing planes when the grasshopper is moving through the air. Under the wings are the different colorations and transparencies of the second pair, the one that is really made for flying. That second pair is the one grasshoppers use to increase their capacity for movement, allowing it to make jumps and even fly. But this kind of movement can become unnecessary in the high and rugged mountain ranges. There, many insects live and evolve isolated from neighboring ecosystems. These islands on land tend to be rich in natural resources, and the presence of predators is limited. This allows for a progressive reduction in the wings, which are simply unnecessary due to the fact that there is no need to flee or migrate in search of food. The uselessness of the wings became more and more evident until nature, in its mission to adapt the animal's body to its environment, eliminated them altogether. It is this mission that is behind all of the adaptations in the insect world. For this reason, some species of cockroach do not fly, and others with their wizened wings do so clumsily and have limited autonomy. Sometimes the first pair of wings only partially hardens, and they can be used to protect the second pair, which is kept in a membranous state. That is the case with many species of bug. These insects, although poor flyers, have their flight requirements perfectly satisfied, these practically amounting to moving to where food is located. In fact, some of these species have completely lost the ability to fly, as they do not need to move about because they act as parasites. Beetles, members of the Coleopteran group with more than 300,000 known species, owe part of their extraordinary biological success precisely to the complete hardening of that first pair of wings, or elytra. The elytra close hermetically over the second pair that is thereby protected inside a highly resistant sheath. The elytra are said to have a variety of possible uses during flight. They can, for example, stay open and immobile during the trajectory of flight, thereby acting as planes of equilibrium, whilst the second pair of wings is responsible for providing propulsion. Others keep the elytra closed during flight. First, they verify that the elytra are functioning correctly, and they extend their antennae to check the air currents. But in spite of that technical precision, its ability to fly is in line with its robust and heavy appearance. Its flights tend to be short and slow. Specific environmental conditions have come together over the passage of time and led to the complete fusing of the elytra in some species. In these cases, the sheath's only purpose is to provide sturdy protection for the animal's body. However, when it comes to butterflies, wings reach their maximum expression of elegance and beauty. The Lepidoptera. There are approximately 200,000 known species that fly over the ground with those two pairs of wings, the physical attribute that makes them most recognizable. Nature, as if conscious of the importance of beauty, has created an almost infinite variety of combinations in butterfly wings. The cause of the butterfly's enormous capacity for conquest and adaptation appears to be quite clearly down to that most distinctive physical feature, the wings. The image of the wings seems so familiar that only one characteristic surprises us: their large size in relation to the body. However, the insect's overall dimensions do not follow any strict rules. An undefined space between our fingers represents the dimensions that man normally attributes to the butterfly. The diversity is especially evident in the spectrum of different dimensions that these insects have. The average size of moths is just a few centimeters, but some species barely reach a few millimeters in width. The same can be said about other butterflies. In some cases, the differences in size are truly spectacular, especially if you consider that you could be talking about members of the same species. However, the size difference does not prevent all of their bodies from sharing some common characteristics. The wings are the most eye-catching part of their body. However, that characteristic is not only distinctive because of its attractive appearance, it also constitutes the highest grade of specialization achieved by the coloration of insects. Triangular wings supported by a network of veins that give them solidity and consistency for flight. The beautiful colors of the wings are due to a combination of flattened scales that can be up to 90,000 in number. They are perfectly superimposed one over the other, as if they were miniature tiles. However, the presence of the scales is not only for aesthetic reasons. They are also used by the butterfly as efficient indicators during flight. In some cases, the precise distribution of these scales fulfills the function of keeping the brain informed of the conditions under which the insect is flying. The countless forms that butterfly wings can take entail extensive possibilities for visual language. Nobody can deny that they are in fact a never-ending spectacle. Quite apart from the unquestionably striking aesthetic outcome, the ample variety of wing shapes has the function of allowing the members of the different species to recognize each other, thereby avoiding erroneous copulations. Sometimes the colorfulness they display cannot be appreciated at first sight. It is as if the insect hides the secret of its beauty, keeping it concealed and only showing it off during specific moments of the day. Some insects are capable of refracting the light that hits their scales thanks to the structure of their pigments. The light is then dispersed over the wings, drawing pretty flashes of mother-of-pearl that appear to prove that there are no limits or boundaries. The change in the incidence of light on the colors can become a truly hypnotic spectacle. The wings of the butterfly contain so many secrets, so many perfect forms of adaptation to different environments, that one might conclude that its aesthetic beauty is the least important factor. A thought that is nevertheless difficult to accept when you take in their beauty. In the beetle kingdom, we can find attributes that are no less surprising. The spectacular development of the horns in some species gives the male a truly intimidating appearance. And makes for a curious contrast with the Pacific female, who dedicates herself exclusively to the task of procreation. The sexual dimorphism can become so pronounced that they appear to be insects of different species. There are physical differences between males and females whose purpose lies in the amorous engagement. The beetle's horns are not only used in battle. On many occasions, such intimidating protuberances can fulfill a seductive function prior to copulation. It is normal for the females to select the males with the largest attributes, female and male both from the same species. This fact is not only applicable to the heads and thorax of the species. In some species, it is the legs of the males that grow to disproportionate levels. The purpose of this disproportionate difference is not capricious or coincidental. The long legs are used by the male to mount the female more firmly during the act of copulation. The reason is therefore the one initially pursued: optimal copulation, guaranteed reproduction. Exaggerated disproportion can also appear in the hind legs. The modification made by the insect does not affect the length of the legs, rather it makes them very wide. The long and muscular legs of this beetle would be the envy of any athlete. Nevertheless, it is incapable of jumping. Sexual attraction is once more the purpose of the deformity. Methods of courtship and seduction that are nevertheless not always based on demonstrations of power. Sometimes sexual dimorphism is so pronounced that the jaws of the male can cover the entire body of the female of his species. Jaws that are bigger than the male's own body. Jaws that are imperceptible on the head of the female of the same species. The differences between male and female are the best symbol of the unlimited world of prodigious insect designs. In butterflies, these differences are expressed through the characteristic beauty of those insects, essentially in the coloration of the wings. In general, it is the males that display bright colors, which they shake in a showy way. During the flights they use to attract the female, a spectacular way of drawing attention, which has a lot to do with the survival of the species. For that reason, the females display duller colors. Inevitably, they will have a better chance of going unnoticed to the eyes of a predator. Another form of dimorphism is seen in the antennae of the males of some butterflies. They are capable of detecting the aromatic scent emitted by females to attract them from kilometers away. That is the reason for the pronounced development of its feathery antennae, a phenomenon that is very common in nocturnal butterflies. The opposite case is less common, where the males irresistibly attract the females thanks to the substance they emit from the hairy glands on their wings. All of the world's cultures have used and been enriched by the image of the insect. The Maya, one of the richest and oldest civilizations in the world. The many objects that make up their legacy are rich in iconographic references to insects, towards which this mythical culture felt a fascinated veneration that is shown to be completely justified by the appearance of some beetles, whose shapes and colors make them the center of countless legends. The Egyptians, holders of scientific secrets that have not yet been deciphered today, claimed that certain beetles had supernatural powers, considering them to be symbols of immortality and the forces that guide the stars. All of this was probably due to their ignorance of metamorphosis, an ignorance that led them to dream up incredible fantasies. A text from the era read, "The beetle sinks its ball into the earth, where it remains hidden for 28 days. On the 29th day, which the insect recognizes as the one the moon joins with the sun, It opens that ball, and beetles emerge from it. A threatening phrase very often used in the so-called holy book of Christian culture begins, "Like a plague of locusts, the divine lightning will strike the godless, the non-believers, and the violent." It is therefore not surprising that over the centuries, insects have fed the imagination and sometimes the superstitions of man. The wars of medieval Europe: blood, death, and fire. Fire that the ignorant German peasants blamed on the beautiful, and in this case also innocent, stag beetles, insects that, according to legend, carried burning sticks in their powerful jaws that allowed them to light up the night. Insects, tireless providers of encouragement to man's capacity to dream up legends and myths. A capacity that manifests itself in ways as diverse as Renaissance art and popular cartoon characters. They have always inspired an endless number of stories, myths, and legends. If anyone thinks this claim is exaggerated, they only have to search their childhood memories for some forgotten story. Hard-working ants, or a cicada that, exhausted and alone after having spent its fortune, enters an unsuspected world of solidarity. The myriad and spectacular colors of butterflies have inspired artists and painters across the ages. They say that in ancient times a tailor was commissioned to create the most beautiful dress ever made, which was to be worn by the daughter of a great Chinese warrior on her wedding day. The tailor spent whole nights trying to find ways to achieve this task. They say that he finally found the solution on the last day allowed to him, when, exasperated by the lack of inspiration, his eyes alighted on a butterfly that rested on his work table and spread its wings. The image of a butterfly today transcends time and space to bring us back to that Chinese tailor and the most beautiful dress ever imagined. Which reminds us of a great British entomologist and writer who had a great knowledge of the many stories that make up the 1001 Nights. He believed that the secret of Shahrazad's beauty was in her eyes. It was said that she powered her eyelashes with the dust from the wings of a butterfly that was caught in the mating season, which turned the soft fluttering of her lashes into a silent and irresistible seduction. Like a lighthouse on the edge of the earth, a butterfly's wings evoke age-old memories. Whether based on truth or imagination, legends often include the fascinating figure of certain insects. Given the profusion of insects in our myths and legends, it is not surprising that our imagination continues to be dazzled by them. Creatures that sometimes look like jewels, precious stones shaped by a visionary craftsman determined to seek prodigious new forms of beauty. There are also species that send out their own light thanks to the peculiar structure of the superficial layers of their armor, which break up and modify beams of light, producing fascinating flashes of color. It is interesting to note that many insects appear to be sculpted by hand. In a sense, you could say that is precisely what they are. The sculptor was nature itself, working with the tools of evolution to perfect its creation over the ages. Without a doubt, nature has outdone itself with the design of some beetles, their elytra crowned with dazzling metallic sheens. The sight of a ladybird walking along the leaf of a plant just before it flaps its little wings to take flight. The fascination produced by seeing the myriad colors of a butterfly floating among flowers of many colors. The image of a grasshopper about to launch off in its inimitable style. Who among us does not have distant memories of such wonders seen through the eyes of a child, keen for greater knowledge that it is not yet equipped to acquire? Images from the past, moments that bring us back to our own childhood, and a world view that perceived insects as a completely natural part of everyday life in a way that seems lost to us today, being no more than a memory. Nature, as if aware of mankind's desire to collect and compare, has written a chapter on record breakers. The name of this beetle, Titan, seems completely justified. It is the biggest in the world and can reach a length of 20 centimeters. The Goliath beetle, meanwhile, is the heaviest, being able to reach a weight of up to 100 grams. Seeing it on the weighing scales, we have to ask ourselves if insects really are ugly. Is the problem in the eye of the human beholder, which is incapable of seeing the richness hidden inside? So many and varied life forms could not but fail to awaken our scientific interest. It is hard to imagine the countless times that human intelligence was put to the test to try to find new scientific names for these creatures. The insect universe reveals new unknown species to us with every new sunrise. It could be said that the designs, colors, and varieties of beauty applied by nature in the insect universe are prodigious and infinite. It is humbling to think that the planet could go on without mankind, but not without insects. To see the land and seas from above, to be able to conquer the skies, to fly. If we consider the feats that insects can accomplish, we can't but envy these abilities. Envy them and close our eyes to imagine, for as long as our imagination allows us to, that we too have wings and are free to explore the space beyond the sky.